hate paperwork. Don't make me fill out forms.
I thought teachers love paperwork.
Different than grading. Different.
Because they give out so much paper.
That's different. And also, how much paper have I given y'all?
Let's count.
Book. Book. Period.
There's still paper, also the review.
Okay, reviews. Chapter reviews to help you with your test. Oh, snap. Okay. Right. Like, thus far, we're at one packet.
The book counts.
Let's look at this. We're going to be on page 38 in your workbooks. What's that?
What?
I said, what's up?
He has a hoodie t-shirt.
Okay. You seem very concerned by that. You were wearing a hoodie. I was like, I have t-shirt hoodies, like made out of t-shirts. Hoodies made out of t-shirts, but.
This store got burnt down. I can't.
I see a Nike on it though.
All right, let's look at this. Page 38. Y'all, I know we're squirrely.
It's already Friday.
It is not. It is Tuesday.
Yeah, it feels like Friday.
It's Tuesday. It's Tuesday. Lock it in. All right. So we're working with equivalence again. We did it in the last chapter when we were looking at equivalent expressions, where they mean the same exact thing. Now we're looking at equivalent equations to see if these are equivalent or if they are not equivalent. Mostly what that is did they do a okay math thing to get from the left one to the right one?
Yes.
What did they do to get from here to here?
Plus 2x.
They added the 2x. They did plus 2x to this side, plus 2x to that side, which is an okay math thing. We are allowed to do that. 7 plus 7x equals 3. I can't think of a time when we're not allowed to add x to both sides.
Stats.
Okay, in stats, you can't play with the stats too much. That's a whole different beast.
Yeah, but still, you said in math in general.
In general, generalized. So yes, these. So all we're really looking for here is that this piece is equivalent to this piece. They mean the same thing. I could get from here to here following all of our normal math rules. You're gonna make me be so specific with my words. Okay, let's finish it out. Let's solve it.
X equals -4.
What would we do to solve this, guys? -7. So we get that 7x equals what? -4. And what would we do to get to our x equals? Divide by 7. So our x equals -4 over 7. What? I was. It happens. That's what happens when I talk and write at the same time. All right. So these are all equivalent. So if we wanted to keep going, we could say this piece is equivalent to the other equations. And this piece is equivalent to the other equations. They all mean the same thing. They're all going to get down to that x equals -4 over 7. Which I don't like that. We're going to do that again with a chunkier highlighter so I can fill it in better. So it's going to take me an eternity. There we go. So all of those pink highlighted things are equivalent. They mean the same thing. Now let's look at the next one.
Not equivalent.
Oh no, they ain't.
Did they?
No.
Just completely.
They did something to where the 3 is gone in the parentheses.
Yeah. They just straight up dropped the 3. Over here, in order to make this equivalent, they straight up just dropped the 3. So where did it go? They straight up just drop the 3. It's not something that we can do. We can't decide we don't like a piece and then just get rid of it and throw it away.
No.
What should they have done here? Option 1 is distribute. So we could distribute our 3 and get, what would we get? 3x minus 12. Oh, let me change the screen real quick. Equals our 15. Other option, if we don't like to distribute, what else could we do to get rid of this 3? We just did that one. I'm looking back up over here. Not subtract, but you're headed the right direction. So option 1 is to distribute. Option 2, not multiply both sides, but super duper close. Divide both sides by 3. If I divide both sides by 3, we'll get that x minus 4 that they had, but it's going to actually equal what? 5. So a lot of you guys went distribute like this. Totally fine, absolutely valid. You could also divide both sides by 3 instead of having to distribute. Both of those are valid. So this piece and this piece and this piece are all equivalent. Those 3 things all mean the same thing. But it's not that x minus 4 equals 15. They just dropped the 3. Okay? So there's more than one way through these. There's not just one pathway through solving these. Let's keep rolling with this. Keep practicing. How about here? First question is, what did they do to go from left-hand side to right-hand side? They divided by x. To get from here to here, they divided by x. Is that something we do? Not unless we can really, really help it. Because if we have an x squared, you saw this in Algebra 2, what does this look like on a graph? What does an x squared look like on a graph? A u, right? It's our parabola. You had it. Looks like this. If I have just an x, what does this look like on a graph?
A line.
A line. So I've changed it from a u to a line. And that's not cool. You can't do that. So what would we need to do in order to solve this? Do we remember? It's been a hot minute since we worked with an x squared. I got an x on this other side, so I can't square root it. If it was x squared equals 36, I could do that. We would need to make this be x squared minus 6x and set it equal to 0. So that we could then factor. We're not going to need to do that necessarily right now, but we could because we're super duper awesome like that. But we will focus on quadratics more when we get to chapter 5 next semester. We will get there. It's it's one of my favorites because it has my favorite activity in it. My most favorite activity is the opening of the quadratics chapter.
What do we do?
We build catapults and launch gummy bears down the hallway.
You serious?
Serious. Dead serious. My favorite
Why did we
activity.
start with that?
Because it's when we intro quadratics. Because it's the flight. Our favorite activity. My most favorite activity. It's the most fun. I think. No, we literally build catapults and launch gummy bears down the hallway.
Labor Day.
Not every day.
Oh my God.
We'll do it for a day. But it's fun. Okay, so we're not going to focus too much on our quadratic stuff, but it's important for us to notice that we're not going to divide by x. That's not a thing that we do unless there's absolutely no other option. All right. Now we have an icky. Take a look at this one. What do we think about this one?
We know.
What did they do here? What did they do on this one? This one's number 4. Random. What did they do to move it to the right side? Because you're not wrong. Yeah, they multiplied both sides by their denominator. They took our x minus 5, x minus 5. And they multiplied both sides. On the left-hand side, it cancels out, giving us 1 equals, and that's what they wrote on the right, 10 times x minus 5. They multiplied by the denominator. Is that a thing we're allowed to do? Yes. Why are you shoving my tables, y'all? Make sure we put it back, because you're making that walkway for the tables in front of you real small. So yeah, this is a thing we can do. It's not typically something that we do with a lot of x's in it. So we can multiply by it. It's how we would solve this to make it way less gross. It does make a weird thing happen. You've seen this in Algebra 2 because we talked about it. Because what is the one thing a denominator can never equal? What is the one thing? Yeah. The one thing we can never, ever, ever divide by is 0. So this would add an extra rule on there saying that that piece can't be 0. But other than that, it's totally fine to do. It's not comfortable, and it's not pleasant, and it's not going to be something we see often. But they had it in here, and so I wanted to talk about it. What's up? Okay. Okay, so looking at these expressions, or these equations, and finding the equivalent expressions, how this thing is equivalent to this, and how all of these were equivalent, and how we could tell that these ones weren't because they just straight up dropped the 3. That is entirely what homework 2.2 is about. And you guys have 20 minutes.
Well, I already did it yesterday.
Awesome. I'll grade it and give it to you. So, give it a shot. Try. It's on Canvas. You guys have 20 minutes in here. We should not wind up with this one missing. Okay? Work on it. If you got questions, ask questions. I'm here to help. But I'm giving you time now to work on it. It's using exactly what we just did. Did they do an okay thing? Is it not an okay thing? Are they equivalent or are they not equivalent? How do you know?
Sorry.
Nah, I said I'm
I think you should be short. Hey, let's go ball.
All right, if you want like proper math rules, like what we did, how we know, they're written out for you guys on 31 and 32. It looks like this. It's the official math rules. But it's really just about the fact that we can multiply things to both sides, or we can divide both things. All that jazz, okay? So work on stuff. Let me know if you have questions. I'm happy to help. But I want to give you guys time to practice it because it's a little awkward.